Stan Gibilisco here. I'm just going to tell you how you can pick your own voltage in a voltage divider network, a very simple two-resistor voltage divider like this one. Here is the supply voltage, whatever that may be, the positive terminal of a battery. Common ground is always 0 volts. Positive terminal of a battery, the negative terminal of a battery, an external DC power supply. The important thing, though, is that it be a DC voltage. You can pick any voltage you want between this voltage V and 0 or ground, any voltage V sub 0 that you want by tweaking the values of these resistors. Now you can calculate this with a specific example. Say this is 12 volts, this is 1000 ohms, this is 3300 ohms. What will V sub 0 be? You can actually calculate that by calculating the current through the circuit and then using Ohm's law again. You can calculate the current using Ohm's law, and then you would remember that the two resistors add together in series. Then you would simply figure the voltage drop across this one and the voltage drop across that one. Now, the important thing to consider about this point right here is that this whole scenario applies to a no-load situation. That means that whatever you connect to this point right here has to have such a high internal resistance that it isn't going to disrupt or weigh down this circuit very much. That it's going to have a resistance far, far higher than either R sub 1 or R sub 2. So you want to make these values as low as possible. That way you can use a load that might have a little bit of resistance in it, or I should say a real lot, but not a very heavy load. Okay, so that's all figured out. Suppose that you want a specific voltage V sub 0. You just want to get that voltage. How can you calculate that voltage? Well, remember that the voltage drop across a resistor is equal to the product of the current through it and its resistance. So whatever you do here, you want to make sure that these resistances have the correct ratio. But there's a trick. The important thing is the ratio of this resistance R2 to the ratio of the entire sum of resistances, in this case only two resistors. So what you want to do then is, the formula is really very simple. V sub 0 equals V, whatever that is. You can never get a V sub 0 that's greater than V. You multiply that by the ratio of R sub 2 to the entire resistance R sub 1 plus R sub 2. Like that. That's all you need to do. So you can calculate these values using algebra in either direction, but that's the important thing. This voltage V sub 0 is going to be equal to a fraction of this power supply voltage, and that fraction is R sub 2 over the quantity R sub 1 plus R sub 2. It's really that simple. It doesn't matter what the actual resistances are. They could be in the tens of ohms, the hundreds of ohms, the thousands of ohms, even the millions of ohms. But in general, the lower the better, because it'll help to tolerate this no load ideal so that you can in fact connect something to it. Ideally, that something would have a very high impedance, such as the gate of a field effect transistor or under some circumstances, the base of a bipolar transistor, or one of the grids in a vacuum tube if you're into that kind of thing. So that's how you can do it with a voltage divider network. Another caveat, though, is that if you make these resistances too low, you're going to have a lot of current through them, and you want to make sure that they can dissipate that power that's going to be imposed on them by that high current. So use this formula. Multiply the power supply voltage by the ratio of the resistor between the ground and V sub 0 that you want to the sum of both resistors. Stan Gibilisco signing off from the black holes of Dakota Territory, United States of Advertising. Until next time, so long.